looks like we're going to kick this off, second half of this webinar today. We're going to talk about right sizing your lubrication program, staffing decisions based on a calculated labor requirement. Presented today by Mike Johnson. He's the president of Amory and Generation Systems Incorporated. It's going to be a fantastic 59 minutes. Look forward to hearing this. Why don't you kick it off, Mike?
Thank you, Mr. Holloway. Very much appreciate that. I'll do my best to make 59 minutes. Tend to talk a little bit fast when I have the opportunity to do so. I'm going to get into the process. Now, a little bit about me. 33 plus years involved in machine reliability improvement for customers, including lubrication practices development, vibration analysis, other condition monitoring technologies. Like our other speakers, I've been fortunate to be at the right place at the right time, many times, to have added to the total of the body of knowledge for our specific technical interest. Before I get into the meat and potatoes of our discussion, I want to take a look at a high-level concept again. Just repeat this. I mentioned this last time around, but I'll hit on it again. I want to stress the value of precision lubrication in just a few slides before we get into the nitty-gritty detail. It has been said that our industrial world floats on a 10-micron film of oil. And we know that it's not entirely true. It's more like 1/2 to 5 microns, perhaps as much as 10 microns in the occasional plain bearing application. The fact is, our livelihood floats on an oil film that's the thickness of a red blood cell. And accordingly, we have a very little margin of error between it's working properly and it's not working at all. According to the folks that study these things, and I'll point out to Professor Ernest Rabinowitz here, machines lose their utility to a variety of things, including obsolescence and breakage, but mostly machine function is lost to surface degradation. And most of that surface degradation occurs due to the internal wearing of lubricated rotating equipment parts, wear from adhesive, abrasive, corrosive, and surface fatigue means. Now, further to boot, in addition to machine wear, energy-related losses and wear-related losses combine to account for something in the neighborhood of 6 to 7% of a country's gross domestic product. Well, that is, regardless of the size of your economy, that is a very, very large number. So it certainly behooves us to focus on the quality of our machine lubrication work process to assure that we have precision lubrication functions in place. Our part providers are quick to show us the relationship between lubrication effectiveness and lost lubricated part performance. Here's an SKF chart where in their documentation they show 57% of the time that a component fails prematurely, there is a lubrication-related complicit underlying reason: inadequate lubrication, contamination, or wear. Not to be outdone, FAG Bearing Company says that it's not really 57%. For their research, it's 75%. Insufficient lubrication, contamination, unsuitable lubricant, aids lubricant. And whether it's 57 or 75, that doesn't really matter. That is, for both companies' representations, a very large reason for why components, element bearing components, would fail prematurely. We know the reason that the parts fail. Component failure modes are wear from surface rubbing, wear from contamination, wear from fatigue and corrosion. These are our dominant failure modes, but regardless of the failure mode, when components fail, we lose productive time to both scheduled and unscheduled repairs. We lose machine repeatability when our machine parts begin to wear down, wear out, and that contributes to lost product quality. We have an increased risk of injury, particularly if we are scurrying around attempting to accomplish unscheduled repairs, get our machines back up and running as quickly as possible, the risk of increased lost time injury greatly increases. All of these causes, underlying causes, drive our product cost per ton or cost per unit measure, all of which contributes to lost competitive position for our enterprise. So machine lubrication is an essential element, and I would argue the most important daily activity the workman has to deliver to the plant site to protect machine reliability on a daily basis. Our objective with our lubrication program should be to provide, with our daily care and feeding activities, a continuous coating of oil or grease that provides cushioning and sealing for the machine's lubricated parts to prevent wear and corrosion. And if we're able to do so, we can expect to see reduced replacement of lubricated parts and labor associated with those part replacements, reduced contract labor from planned outages or unplanned outages, and certainly an increased net production output. Regardless of the fact that the first three bullet points here represent very large dollars in potential return back to the enterprise, those numbers pale in comparison to the benefit of increased productivity without the purchase of new capital equipment. So once again, just to punctuate the importance of this day in, day out routine, the lubricant film failure modes are measurable, predictable, and avoidable. And if we have a well-defined, well-delivered precision lubrication work plan, we can certainly expect to avoid those failures. So with that as a backdrop, let me step into the idea of right-sizing a lubrication program, giving us the means to make staffing decisions for our machine lubrication work plans based upon a calculated labor requirement per asset, not based upon what we did last year, the year before, or 10 years ago. Now, this is all driven by the machines that we choose to operate for whatever production unit we happen to be talking about. So consider a pump. We don't lubricate the pump per se. And the pump would be considered an asset in everybody's nomenclature, an asset or a drivetrain. Our objective isn't to schedule a pump for replacement. It is to schedule the motor and the coupling and the pump body itself for service. The motor would have two bearings, inboard and outboard bearing, that each may require different service plans. Many of our couplings are not lubricated. Still, we have some that are. We have a coupling, a subcomponent level item that must have a plan. And then the pump body itself would have its own separate plan. If you think about a simple, waiting for the slide to move forward here. Mr. Holloway, what slide do you see on your screen, please?
There's a time requirement per task. You get that?
Yeah, it's not scrolling here for me.
Now it changed over to lubrication program details.
Okay. All right. That's where we needed to be. Sorry about that, folks. Okay. So if we consider a single critical pump and each of the subcomponents within the pump and the service plans for each subcomponent, we have a motor, two bearings, 2 events per year, 4 tasks or 4 events for the motor, 2 tasks per year for the coupling, 52 tasks for the year, including a routine level check. Maybe we're doing oil analysis, maybe not. Probably 1 task per year for an oil change. A simple critical process pump can actually require somewhere in the neighborhood of 63 to 67 tasks per year. And each task requires a time allocation. Now, for each time activity, we have the legitimate time that's required to do the work that must be done. Scheduled level checks, top-up activities, scheduled grease replenishment. checking of metering glasses on supply systems, replacing filters, topping up tanks, and a variety of things of that nature. In addition to those legitimate task requirements that must be accounted for into the task allocation, we also have to account for other miscellaneous work that we do due to poor machine health, such as continuously attending to a leaky oil system. Well, doing it again. There we are. Account for broken or missing automation. These would be simple items that the workman might be doing on a routine basis to make sure that feed lines are intact and working properly, pressure gauges, level gauges, those kinds of things are working properly. Lastly, we have to allocate time that is necessary but not necessarily productive time. Walking around time to get from the meeting room out to the machine, cigarette break time, going to the buggy to get another tube of grease, going to the storeroom to get another box of grease, that kind of activity. So there's all kinds of activities that have to be accounted for. Whatever the number of tasks, we have to account for those activities. So let's boil this down into a component by component look. Let's say we have electric motors that are less than 25 horsepower and are in a horizontal orientation. We're going to re-grease those motors. We're going to allocate time at that inboard, outboard bearing. We've got 2 points per motor, and we're going to allocate 3 minutes per task. We're going to do this on an annual basis or every 360 days. So we're going to have one event per year. 2 times 3 times 1 gives us 6 minutes per year, or 0.12 net hours per year. If that same motor happens to be in a vertical orientation, because we are fighting the force of gravity, we're gonna cut that interval in half. It's still a small motor, but it needs to be fed more often. So we're going to have twice as many events. 2 times 3 times 2 gives us 12 minutes per year, or 24 minutes, 0.24 hours per year for that one electric motor. Let's say it's a slightly larger motor. And because it's slightly larger and we have slightly larger components, horizontal shaft orientation, but now we're going to lubricate that motor on a semi-annual basis. If it's a vertical orientation, bigger bearing vertical orientation, we're going to cut that interval in half. As we reduce the interval between visits, we have to increase the allocated number of minutes. Let's say it's a large electric motor. And now let's say it's even a critical motor driving a critical function. So we're not just going to feed grease according to a well-detailed plan. We're also going to use sensory tools to help us regulate the flow of grease while we're there. Of course, the use of more sophisticated tools requires more time allocation. So we have 2 grease bearings, 5 minutes per task. We're going to do this because it's a larger motor. We're relubricating more often, so we're going to do it at a 120-day interval. So we've got 3 visits to the motor. 2 times 5 times 3 is 30 minutes total, half an hour a year. If that same motor is in vertical orientation, once again, the interval is cut in half and our hourly requirement per year is doubled. And we treat all of the other tasks and all of the other activities in a similar fashion. Level check and top up. For 1 point, let's allocate 5 minutes, let's say, to do the level check and top up. We're going to do it at 7-day intervals. So we got 52 visits per year, 260 minutes, or 4.4 hours per year. So if we think through our collection of components and assign a timestamp and a typical interval to each of those components, we begin to see what we have in place. Let's say it's an agitator that's somewhere between 5 gallons and 44 gallons. We have a couple coupling task requirements, an 18-month purge, and a 3-year service interval. And just a side note here, our coupling manufacturers will tell us to purge at 6 months and break the coupling down on an annual basis. and I'll get into this at the end of the presentation, if you're using higher performance lubricants, you can often extend the service intervals through higher quality products than we would if we're limited to using commodity-based products. So as you think about shopping for coupling grease or bearing grease or oil for whatever kind of application, keep in mind there is oftentimes a correlation between the price you pay and the quality of the product, and therefore the amount of labor that you're going to have to expend on a given day, week, month, annual basis to cover your machine's lubrication requirements. So back to the agitator, a relatively small sized agitator, a couple coupling tasks. We've got an oil level check top up task, an annual drain and fill, a 3-year sump flush and fill. We have bearings on the top, bearings on the bottom, and then perhaps we even have a sump sample activity. Now, if we have all of these kinds of activities, we probably won't be doing an annual change if we're also doing oil sampling. But let's just say for the sake of it, we're doing all of these activities. That's 444 minutes or 7.41 hours that we can calculate up for a single agitator. Well, you don't think of an agitator as taking a full man day per year, but by the time you look at each of the component requirements, you see that's what you have. An oil-filled pump, assuming there's coupling to attend to. We attend to the couplings. We have a level check and top up, drain and fill, and a 3-year sump flush and refill. That's average of 5 hours per year per each oil-filled pump. If it's a grease lubricated pump, we have less trips to take, less net total hours per year, but once again, we can calculate out precisely how many hours we should be allocating according to that asset by type. So when we begin to tally up the total number of tasks and the total time requirement per year for our machines, we can see pretty easily what the net total hourly requirement will be. A single critical pump, 58.2 tasks, 5.42 hours. A single direct coupled force draft fan, 52.9 tasks, 3.97 hours. A single critical conveyor, 202.1 tasks, 17.1 hours per year. When you throw all those things together, and let's say it's a fairly small asset population, 30 conveyors, 30 fans, 500 pumps. It doesn't take many assets before we can find ourselves measuring out and demanding a requirement for a large number of man hours. Now, this would be considered a fairly small production facility, yet even with only 560 assets doing something in a production mode and simple assets at that, we had 36,570 tasks and 3,342 man hours, a year and a half, slightly more than a year and a half of manpower required to tend to just these few machines. Regardless of what we did 5 years ago or 10 years ago or 20 years ago, we've got to think about what our actual machine footprint requires of us today, and particularly in the era where our work practices, our work teams are disrupted. We're running split shifts. And looking forward, we don't think it's going to be business as usual. For the immediate time frame, we got to begin to think through how we're going to allocate labor. So that's kind of the big picture. Let's dig into the details a little bit more. And I'll start with the summary of different kinds of tasks that the team that I've assembled has managed to pull together. Now, this is a chopped up piece of the worksheet. We got 54 total tasks on our list as of today. And if you have an interest in seeing what the task list is, by all means, at the end of the presentation, drop a note in the form that you see. I would be more than happy to send this to you. So these are generic tasks. Each task has an interval, and each task at that interval has a time allocation. You might not like our time allocations. You might like them. It doesn't matter. Whatever. you pick the time allocation that's the best fit for your operating environment. And this is just intended to be a starting point. Step 1, assign a time value for each of your many task types. Step 2, now that you know how much time you're going to allocate per task, you need to know how many tasks there are to be conducted at your plant site. So go out and collect a list of all of the lubricated machine parts for all of your rotating assets. For our part, this is a very detail-oriented kind of work to be done. And we know that we need to keep our details very well organized. So we use forms like you see here. Once again, if you want to take a look at the form, please make a notation in the form, box you see at the end of the presentation. Be happy to send that to you. Step 3, once you have collected all your machine parts for all of your assets, organize the machine parts into specific asset groupings so that you have a layout of all of the machine parts for each given asset. You have a good accounting. You know you have a thorough accounting for all the machine parts. Step 4, once you have allocated tasks by asset, you want to assign an interval, 7 days, and the duration, 5 minutes per task, so that you can aggregate the total number of minutes required per year. So 5 times 52, that's one visit each week, 52 weeks times 5 minutes per visit to do that thing is 260 minutes. So we now know how many minutes to allocate for level check and top up on the R2 agitator. Once we have done that for each component, we got the 262 minutes for that task plus all of the other tasks in the production cell. We come up with a total number of minutes, which quite easily divides out in the total number of hours and or man years required for these machines in this production cell. Now, once we have the details in hand, if we are using a task management system, and then we can take those details, plug them into the task management system, and as long as we're doing it again. As long as the detail is provided in your task management system as a data field and not a text field, then your system should give you the means to aggregate all of the data fields so that at the end of the exercise, you will know how many hours per week, per department, per machine, annual hours per year, and it should all roll together. So we have an activity, a regrease activity. We've allocated 5 minutes in our machine database setup configuration. We make a notation in the right spot, duration of 5 minutes. Here's an example of electric motor bearing. We have oil lubricated motor bearing. They're going to change at a 6-month interval and allow for 30 minutes, top off on a weekly interval and allow for 5 minutes. Now, whatever the intervals are, whatever the time allocations are, it doesn't really matter to the computer when it's calculating up total labor requirement. So if we put those details into our work management system, yeah, we're doing it again. Here we go. So once we have plugged in all of the details into our task management system for a given week, we have a given number of tasks in a route. We've got the routes defined here by department and all the tasks that show up in the weekly work schedule. And all of these details are granular data points. So the computer does the adding up of the total number of tasks and the total number of hours required per year. For this particular route in this particular week, we see that we have 31 tasks and 6 hours of work requirement. And as the week rolls forward, if our workman or our program manager is updating the work that's being done, the system should account for the tasks that are completed, 19 of 31, and the total number of hours that have been fulfilled, 2.45 out of 6 hours. So let's say it's Thursday afternoon and I look at the weekly work tally and I see that I need to allocate some extra time to this particular route. Tomorrow's the last day of the week. No worries. I have information that is hard, cold data in advance to be able to allocate additional hours. Now, the point of this presentation wasn't route management details on a weekly basis necessarily. However, if we have the details per task, per interval, per machine, it will give us the means to manage our weekly chore more effectively, and will also give us the means to manage our annual labor requirement. If tasks are well-defined, intervals and timestamps, the system manages each component as a single data point, then all of the time requirements aggregate. So here we have an example of multiple persons involved in lubrication management at a facility. We see the total number of tasks per year in this column, the duration, and then the net hours per year over in this column. So it all starts with a very granular review all the way down to the nitty-gritty detail, and then rolls forward to give us a summary, excuse me, a summary of the hours required for the production facilities. Now let's think about things that can be done given the trickiness of our current times contending with this global bug. And given that our work crews are chopped up into smaller groups of people, we don't have a half to a third of the work team we need to have to get the work done. There's got to be some things we can do to reduce the total labor requirement. Well, the first thing we could do is improve our route efficiency by creating tight linear sequences. So here's an example of a top-down view, a floor plan, if you will, of a production cell. We enter the door to the production cell, and then we predefine what the smallest number of steps would be to address all the machines within this production cell. And we organize the linear sequence of assets one after another following this sequence. That being the case, the workman can look at his whole production requirement in kind of a bird's eye view and see that perhaps there is a more efficient way to get the work done. Now, that'd be a good thing. This work is hard enough as it is. If the workman has fewer steps to take in order to cover all the bases, that's a benefit. Second point, provide cross-training with operators and other technicians, particularly at this point in time, so that we can share the load. We can't wait for the lube technicians to return to the plant site after 2 or 3 or 4 months of being laid off in order to resume the work of machine lubrication. So we do want to share the workload, and the traditional model is the lube tech does all the lubrication work, but that's kind of tribal knowledge-based approach, and that approach is failing before our very eyes in the midst of this COVID-19 pandemic. Operators need to be in front of machines for routine inspections. Let's include at least level check and top-up activities, or consider including these activities to the operator's routine work as an extra means of lessening the load. Okay, I'm going to back up the slide here. There's lots of options available for cross-training. The 4 speakers that are present today offer these classes, 2-day, 3-day, 4-day classes, depending upon what your needs are. Classes are available through web-based and on-site training, and certifications and or class attendance certificates are available. There's lots of resources out there to help you train up your folks so that you can share the load amongst multiple work crews. Point number 3, extend a routine regrease intervals or oil replenishment and or change intervals through the use of higher quality products. No, sorry, I jumped the gun there. Initiate grease sample analysis to validate grease health, a means for reducing the number of visits with a grease gun. or alternately calculate and quantify the interval requirement based upon some of the ideas presented the last go round. There's some tools out there available for you to quickly and simply calculate the replenishment interval. And then certainly there are off-the-shelf tools that can be used once we have a hard interval in place to safely extend through sensory observation. SPM, ultrasonic energy, peak view, these are vibration sensor type tools that are useful to help us validate that the component does not need grease at this particular point in time. And then therefore we can push that interval off in small increments until we finally get it tuned to the most optimum frequency. Point number four, extend routine level check and top-up intervals. An idea regarding reservoirs. So we track our reservoir consumption for, let's say, a 4-week period of time. Where there is no consumption for those reservoirs within a 4-week period of time, we have the means to extend the service interval. You should be careful pushing that interval beyond 30 days, but if we can go from 1 week to 2 weeks, or 3 weeks, or even all the way up to 30 days, then we have substantially multiplied our labor effectiveness. Point number 5, extend routine oil change intervals, and for that matter, grease replenishment intervals by deploying condition monitoring. Oil change intervals should be regulated around the chemical health of the oil. Now, we will sometimes see a suggestion to change oil in a machine based upon a high degree of corruption, solid particulate contamination, or wear debris. But if the oil is not chemically degraded, the oil does not necessarily need to be changed. In my ongoing oil analysis surveillance for several plant sites, rarely do I see a bona fide need to change oil. And those instances will only occur when there's substantial chemical contamination, cross-contamination between process contaminants in the oil or different lubricants than the one that should be in place. In those instances, it makes sense to do an oil change and get a clean, fresh start. But 9 times out of 10, when the lab says change the oil, it's kind of a catch-all in hopes that that might help some other condition that we see there in the machine. Let's focus on routine oil analysis and using that information to drive towards cleaning the oil, not simply replacing it. So, summary, steps to enable labor requirement measurement. First of all, list all the machines. And once we have the list of the machines, secondly, we go back and look at all the components in each machine and make sure we have an accounting of all lubricated components. Thirdly, identify all the component service task requirements. And we can have predefined timestamps for those task requirements. Or we can make that up as we go along based upon the physical difficulty of getting to that component to do the work that must be done. Fourthly, establish the time requirement for each service task. And these two, I just kind of grouped them together. They go hand in hand. Fifthly, establish the frequency for each component task service event. Daily, weekly, monthly, semi-annual, annual. But just as a point, if you have daily tasks, you certainly ought to consider automating those activities. There's lots of automation options available. There really is very little that must be done in the machine lubrication care and feeding realm that requires that you be at the machine on a daily basis. Mostly that's going to end up being a substantial oil leak where we have to go back every day to top up the reservoir. And if that's the case, obviously we need to fix the oil leak, right? Sixthly, multiply the number of task visits by the time allocated for each visit for each and every lubricated component within the plant site. Step 7. Step 7 is eluding us. Tally the net number of minutes per year per machine. And now we have a total number of hours per machine, and then we tally up the total number of machines of a given type for a department, and we have annual hours by department, and then that can be all grouped together to give us annual hours for the site. Step 8. Step 8 is eluding us. Step 8, tally all machines to determine the annual service requirement for the plant site. But if we can manage to address these details on a granular basis, starting with the lubricated part in each and every machine, and follow a systematic, rigorous path, regardless of what our preferences are for timestamps, time allocations per task, we can fairly rapidly tally up the total number of work hours required per plant site or production department per year. Okay, that's the end of my presentation. Anybody have any questions?
Hey, Mike, this is Rich Wurzbach. You had mentioned couplings and about greasing couplings, and that you could extend possibly the intervals by choosing a superior grease. Now, I know we already have specialized coupling greases to prevent separation. Can you talk about, what kind of different technology or design there is in the greases for couplings?
Yeah, coupling greases are unique to that particular type of component. We cannot use our conventional lubricating greases in coupling applications because of the centrifugal stress that is applied to the grease as the coupling goes round and round in circles. When manufacturers are producing coupling greases, they are trying to get a close match between oil-specific gravity and thickener-specific gravity to avoid separation under high G-force applications. So there are specific tests that we look for in coupling greases, particularly the centrifugal separation test, sometimes called the copper centrifuge test. That's useful to give us a sense of the amount of separation that can occur over a 24-hour period under 36,000 Gs of applied force for the grease. And we ought to be looking for that kind of grease. And in as much as the coupling manufacturers are quick to say, replenish the coupling every 6 months and break it down on an annual basis to check the grid, check the gear, check the chains, check whatever's inside for any looseness and distortion, what have you. If we're using the product that is properly designed for that application, we ought to be able to see the extension, a safe extension of those service intervals to cut back on the net total number of hours required for coupling replenishment.
Great. Thanks, Mike.
Thank you, Rich. Good question.
Hey, Mike, I've got one that came up. Actually, it's two of them combined. The first one that came up was related to taking into consideration those routes where you might have to do a lot of climbing to get to the point. How do you take that into the equation? And that goes right in line with another question that was posted by Brad. It states, where do you take into account travel time to get to the assets, move between them? Would you take the total travel time, divide it between the assets? Our route is quite efficient, but the assets are spread out and it adds significant time required to complete the route. So I think both of those questions kind of go hand in hand. You got assets on the route that are spread out in a geographic location and assets where you might have to go vertical versus horizontal in direction.
Yeah, and those are entirely relevant influences on the time stamp, whatever it might happen to be. I did some work in a grain elevator a few years ago, and there were several vertical legs in that grain elevator where I had to crawl, in a few instances, 75 feet off the ground up a ladder to get to a machine to do an inspection. Now, as a 60-year-old man, if I'm doing that exercise, it might only take me 5 minutes to get up the ladder, but then it's going to take me 15 minutes to catch my breath, sit down so I'm not feeling dizzy. And that all has to be factored into the amount of time set aside for level check and top up and or grease replenishment for that specific asset. I would favor picking a nominal time value for the task. Start with something that makes sense to management at the plant site, so we're not bickering about whether it should be 3 minutes or 4 minutes or whatever. And then where there are extenuating circumstances, allow for extra time for those specific instances. Where we have assets that are substantially spread out, the potential exists to reduce labor requirement by improving transportation in some form or fashion. That's kind of a common sense thing, but going back to the idea of deciding how many hours we need based upon village lore for a 50-year-old facility versus actually measuring the job, while it is common sense, we need to quantify the actual time requirements that we have. If assets are vertically biased, lots of assets up in the air, lots of climbing, obviously those tasks are going to take more time. If they're spread out and we have to have something more than bicycles or electric powered buggies in order to get to those assets in a timely manner, that needs to be calculated as well. Good questions. Anybody have any other thoughts? Rich, Matt, Mike Holloway, you guys have any thoughts to add to this?
It reminds me of many years ago, coming off of World War II, and we started getting involved a lot more with preventive maintenance and so forth. Reminds me of the old efficiency experts. That was a new field of engineering that started out a while back and really was kind of like the birthplace of what we're talking about, which is to truly understand the task at hand in terms of a time rate and then associating that as well. So this is really it kind of reminds me of that, the throwback to that, where we actually truly look at not only cost associated with parts and whatnot, but also the labor rate as it affords to the amount of time it actually takes to do a task. And I think you're right, Mike. I think that does change, obviously, from factory to factory and even person to person. So I guess it's your recommendation to not necessarily have something just set down in stone where we have to go back periodically and tighten up our understanding of how long it would take to actually carry out a particular task and making sure that those tasks are right on line and the rate that we have determined certainly makes sense, right?
Yep. Thank you, Mr. Holloway.
Yeah, Mike, I'd like to thank you for this. I mean, the the systematic approach that you have for kind of reviewing what the requirements are, I think this is really timely because I'm sure that there's a lot of folks as facilities start to come back online, or even the facilities that are still being operated now with, say, skeleton crews. We don't know what the future is going to hold in terms of the availability of manpower. And if we can do a systematic assessment of what is really required and possibly reduce some manpower requirements while still ensuring adequate lubrication through things you mentioned, like looking at more advanced formula lubricant that might last longer and require fewer person hours, labor to get those done. I think what you've said here is really timely in terms of the challenges that folks are facing right now.
Thanks, Rich. I agree. Part of my mind wants us to be able to resume our normal operating conditions prior to the outbreak of this problem and the sequestering that we're all going through. But the longer this goes on and the more I listen to experts in our field and various different presentations, the more I am coming to grips with the fact that we are not going to be operating status quo once we get back to service. Once we get back in a normal routine, it's going to be a new normal routine. And to that end, we have to find more efficient ways to go about doing the work that must be done. And also to that end, for our part, Matt, Mike, Rich, this is a time that we can spend innovating to help our customers come up with things, different things they can try to do the work that must be done more efficiently and effectively.
It sounds to me like you're talking an awful lot about oil condition monitoring sensors, Mike, and I might know a guy that's deeply involved in that.
Yes, that's an area of innovation that we absolutely are working on, isn't it, Matt?
Yes.
Definitely a nice little plug. Mike, what you had something that you had one of your slides earlier was a Lubit program. That certainly looked like it was one heck of a good way to actually help manage this. You know, it's something that you had mentioned before as far as going back to normal. Don't know if we'll ever go back to normal, but we didn't go back to normal after World War II. And although that was a horrible experience, well, you know, everything became better because of it. The generations became better. The country became better. Manufacturing became better, as did maintenance. And I'm just hoping that in true American spirit and in global spirit, I should just say American, because there's other countries out there that to embrace this concept as well. You take on a challenge and you look to defeat it. You don't succumb to it. And that's kind of like what we're experiencing here. Now, Mike, with the stuff that you had gone through today, sure does make me feel as if there's a certain amount of factories out there and industrials that are shut down for various reasons, but don't know if they need to be. Maybe now is not a bad opportunity where we could actually go in and truly get a good understanding of, and not a mock-up, but a walkthrough to make sure that our tasks and labor rates and the amount of time and so forth it takes to carry out these duties actually makes sense to where we actually are afforded now that opportunity to tighten up. And I don't know, what do you think?
Well, we have work that's pending to be completed at plant sites. And while I do have concern for my own employees and while they are willing to travel, traveling is a problem. And then beyond that, now we tend to work with Fortune 1000 process manufacturing entities, and they've all laid out pretty strong guidelines about conditions around which they're going to allow visitors back into the plant site to do work that is anything other than, quote, essential work. Now, I would argue daily care and feeding of machines and developing systems that enable very effective daily care and feeding of machines, daily essential care. I would argue that to all be essential. However, now I got 3 customers that disagree with that synopsis, and we're just going to have to wait until their corporate policies will allow for us to resume doing this kind of work activity for them. Now, having said that, in anticipation of the fact that maybe there will never be a return to what we have traditionally done, we are also experimenting with the use of 360 by 360 degree terrestrial scanners, where we can collect a 3-dimensional image from floor to roof, including the walls, the machines, the stairs, the tanks, and everything contained therein, so that we can visit the plant site without having to leave our desks, our office. And while we haven't quite worked out the kinks yet, and I'm not sure that our customer is willing to entertain this as of yet, we expect to be able to create that 360-degree, 3-dimensional image, and then have our customers take photographs of the nameplate details on machines to give us the means to do lubrication engineering with some of the granular service environmental challenges presented to those machines, hopefully through the use of data communications and modeling that's provided by modern technology. We'll see how that works out.
Task for sure. There's a lot of things going on with virtual reality, augmented reality. Absolutely fantastic. Let's see if there's a few more questions coming through. I don't know if Mike or Rich had any come through their portals or not. Let's see. Okay. Looks like we'll probably look to wrap it up here. Please get a hold of Mike Johnson at mike.johnson@amory.com. That's 2 R's and 1 I. Okay. So, Michael, thank you so much for a great webinar. Look forward to many more going forward. Looking forward to learning more from you as well. Thank you all for attending our webinar today. Please feel free to fill out the questionnaire following this as we close out. Thank you so much.
Thanks, Mike. Appreciate it. Be safe. Have a good day.